Hi guys, myself Rastogi. So today's topic is queue in data structure. So in day-to-day life, you have seen in bank uh, a bunch of people are standing at the counter. So they form a queue. Here I have an example also. So if there is counter here, then the front of the queue is this, and the rear will be at the last. Okay, so queue is a linear data structure. So queue is a linear data structure like array and the stack. Okay. So insertion takes place at the one end, namely rear. So insertion takes place at the rear and the deletion takes place at the other end, namely front. Okay. So you can see in this example, as in the queue, if anybody comes, so this is the rear part, this is front. So always a person enters in rear from the rear side and comes out from the front side. So same in this queue data structure. So deletion takes place at the front and the insertion at the rear. So this is also an example I have made. Okay, at the front deletion and the insertion at the rear. So queue is called the first in, first out, or first come, first served. If you have studied operating system, there is a scheduling called first come, first serve. The process which will come in the ready queue first will get the priority. Okay, will get the priority and run first. So same as in the queue, the person who comes first in the queue will get the opportunity first. Okay, so the order in which elements are entered the queue is the order in which they leave the queue. Okay, simple. So there is a queue insertion algorithm, so you have to understand this. So first begin. Okay, queue insert, I have given about 5 parameters. This is queue and the number of elements in the queue, front, and the rear, and the item which we want to add it. Okay, first, is queue already filled? This is checking the is queue already filled. Okay, if rear is equal to n, means the size of the queue is equal to rear. Then write overflow and return. Means if I take an example, if the size of the queue is 5, okay, and the rear is also 5, means the end of the queue is 5 is equal to the size of the queue. Okay, so no element can enter in the queue. Okay, then this is the condition of overflow. Okay, this is the condition of overflow. Else, if there is the capacity, if there is capacity in the queue, else find a new value of rear. Okay, if front is equal to null, then queue is initially empty. Okay, a second case can be if the queue is empty, no element is inserted in the queue. Okay, so means front is null. Then set front is equal to 1 and rear is equal to 1. Okay, as front is null, so set front is equal to 1 and rear is equal to 1. Else, if there is a condition that queue is not empty, then else set rear is equals to rear plus 1, means there are some elements. In this case, there are some elements in the queue. Then will what happen? Then what happen? Set rear is equals to rear plus 1. Okay, and if, then this if will be end here. Okay, fourth point, set queue rear is equals to item, then we allot the item at that place. Okay, return n. This is the algorithm for queue insertion if we want to insert any element in the queue. Okay, then second is the queue deletion algorithm. Okay, if we want to delete any element from the queue, then what we do? So then we begin same. So queue delete, same 5 parameters, queue number, size of the queue, front, rear, and the item which we want to delete. Okay, is queue already empty? Okay, the condition is there is no element in the queue. Okay, if front is equal to null, then write underflow and return. Means if there is no element in the queue, then front will always be equal to null. So write underflow and return. Else, if means if there are elements in the queue. Set item is equals to queue front. We will take the front value in the item. Okay. Find the new value of the front. So if front is equal to rear, this means in a queue there is only one element. Okay. Assume that there is a size of queue is 5 and at the front there is only one element. So the front is equal to rear. Okay. Then set front is equal to null and rear is equal to null. Okay. We will delete that front element and the front will allotted null and the rear is also allotted null. Okay. Else front is equal to front plus 1 means if there is more than one values in the queue means 2 or 3 values, so front will be incremented by 1. Okay, return end. So this will complete the deletion algorithm. The one thing you will remember that in insertion we always increment rear, as we will insert the value from the rear, and in the deletion we always increment value of front as we delete from the front. Okay, so thank you, and if you like this video, hit a like button and please subscribe to my channel.